Hi guys, I'm Shmee, hello and welcome back to the channel where you join me on a beautiful day here at Immendingen in the south of Germany, the home of the Mercedes-Benz test facility, and a spectacular opportunity to discover, explore and find out together what a first drive is like to experience in this, the Mercedes EQXX. This is the very car with which they set a distance on a single charge of over 1,000 kilometers. In fact, even recently, they have driven it from the home of Mercedes in Sindelfingen, Stuttgart in Germany, to Silverstone, ahead of the Formula One. That's over 1,200 kilometers, 1,202, that's 747 miles on a single charge. This is the future of Mercedes, and there's a lot for us to take in today on a very special opportunity for me to get behind the wheel, to go for a drive and to bring you along as well. It's all about efficiency, sustainability, luxurious electromobility, and as I said, the future. We're going to run through the interior, all the different materials, how they use materials from cacti and mushrooms on the inside of it, to the diffuser, which is very clever in the way that it extends at the rear. We're going to learn about that, and most notably, talk a bit more about the powertrain and what it's like when you drive a car that is capable of going, well, effectively 750 miles on a single charge. This must have been the most unbelievably fun, but particularly challenging project that started about 2 years ago with the teams both in Germany, but also working in partnership with High Performance Powertrains, the Mercedes-Benz Powertrains division in the UK, to work on this with the challenge of creating a car that can go as far as this can. We're going to walk around a lot of the technology, and believe me, there's a lot to it, so stay tuned for all of this. Before taking it out for a bit of a challenge to be as efficient as possible, then enjoy some performance, and then come back, because they have a fabulous display of many of the components that feature in this that we can run through and look at in person, a little bit more up close and personal. Now, it is called the EQXX. EQ is the Mercedes electric car brand, and this particular car has a drag coefficient of, get this, only 0.17. Now, to put that into some context, the lowest drag coefficient of any production car is the Mercedes EQS, which achieves 0.20. 0.17 is unreal, and there are many different factors that help play a part in making that possible. The shape, the aerodynamics, everything to do with this, the materials, every single area has been looked at to optimize, to create the maximum, and there are many different things you might be wondering about: the wheels, the door mirrors, the roof, the diffuser at the back, and we're going to go through all of this, I think, starting right around the very front of it. Let's talk about the design of the car. At the front, you've got a very low nose. It's wider at the front, actually, than the rear. It tapers off to have this teardrop style cabin. Things like the Mercedes-Benz star on the bonnet, that's actually a sticker as opposed to a badge to save some weight with it. You've got the full headlight strip that runs all the way across the front, the stars behind the plate just here. Down at the bottom, you've actually got an active air management system with some flaps here that open to help with the airflow for cooling. Now, what they found out when running it is that effectively the car is so efficient that it doesn't really need to have those opened very often. The air then comes up out of the bonnet, that's so it goes up and around the cabin as opposed to impacting any of the other aerodynamics of the car. As you come around towards the side, we've got these air curtains around the very front end which direct and manage the air to come around the side of the wheels and through the curtain behind as well, to minimize the amount of turbulent air outside of the wheels that creates a problem. The wheels themselves are a 20-inch magnesium wheel with both this rose gold finish inside, but also this flat face, which again helps with the air profile, and even with a very specific tyre with Bridgestone that they developed for the purpose for this car, a 185 wide all-round tyre size. As we come down, door mirrors. I touched on door mirrors. You might be thinking, why not put in cameras, because you wouldn't have the air block of those? Well, there's actually a very clever reason for this. If they replaced these door mirrors and took them away entirely, the drag coefficient might go down from 0.17 to 0.169, but it would introduce the requirement to have cameras inside, which would cause a power draw, which would actually be worse than the impact to the drag coefficient, not to mention trying to fit lots of cameras into what is actually a very narrow cabin to obviously optimize the aero profile. Hence, you have these very small door mirrors. Now, they sit just next to the A-pillars, you'll notice it's a very raked windscreen, very smooth design and finish, running over towards the roof where it slopes back. And on the roof, we actually have 117 solar cells so that it can recuperate energy while driving. And in fact, on their full 1,200 kilometer run, they were able to recharge by 45 kilometers of range, about 30 miles of range, just through the recuperation of the solar cells on the roof of the car. The door handles, like on the S-Class, they tuck in, obviously to reduce any drag that they might cause. And we come towards the back with this sloping, low rear line. Obviously that helps with the aero itself, but this is where you have a battle between aerodynamics and between the design of the car. By enclosing it like this, you have a very sporty looking rear end, a huge overhang behind the rear wheels, but you have this diffuser which tucks back in. Now, with it sat in this position, you don't have any ramp angle problems, for example. You know, if it's stuck further out all the time, you'd run the risk of it being a little bit of a problem back there, but by tucking it back in, you get away without that. The magic trick, so to speak, is by extending it. Now, this happens automatically at 60 kilometers an hour, about 40 miles an hour, and it will tuck back in at 40 kilometers an hour, about 25 miles per hour, but effectively it extends. And I'm going to demonstrate that very quickly, so allow me to pop round and just give you a quick show of exactly what this will do. If I hit the button to extend that out towards the back, this is where it lines up to give you the best optimum design or aerodynamic profile that you can possibly have from it, to keep it streamlined at speed, to keep it obviously able to achieve some of the figures that it does. Let's have a quick look at the interior before we get to the powertrain. So inside here we have a very modern but very realistic cabin. That's one of the things I actually really quite like about this. It hasn't gone too far. It's something that could, or you could imagine, as a production vehicle. We start behind the steering wheel with a 47.5-inch display completely wrapping around the front, an evolution of the hyperscreen that we find in the EQS, but suited for a car aiming for lower weight. The materials are really quite interesting, so take a look at the seats. The leather replacement used for these is actually a material that comes from cacti, and you have a material that's created from mushrooms to create the inserts. We have 3D printed components all around the center, on the steering wheel, and everywhere you can look, again, saving some weight and very much looking to future technologies. We have Dynamica for all of the finishes around, even on the steering wheel. We actually have a carpet from bamboo. If you want to save even more weight, you could take the carpets out, but the carpet is made using a material from bamboo. So you see the sustainability elements and angles of all of this as well. Now, touching on the powertrain, we have a battery sitting very low and flat throughout the entire car. It's 100 kilowatt hours. Now, the big clever trick about this is that they've managed to package it to be only half the size of a comparable battery in a production EV. It's only half the size of that, for example, found in the EQS, which is a slightly larger battery, but not significantly. And not only that, but it's also 30% lighter. That means the power density is unheard of. The power density that this can help produce is very much next generation, very much looking to the future, very much what I think we're all hoping is going to be available for us down the line. Now, with this car, before we go out for a drive, well, actually, do you know what? Let's hop straight on in, because we'll touch on things when we come back. So we're going to be joined by Julian from the team that's been involved in the project to go out for an efficiency run to see what it's all about. Here we are then.
Yeah, welcome to the EQXX, Tim. I hope you're going to enjoy your efficient ride. We are going to take a trip through the test track, and you try to drive as efficient as possible, and then in the end we will see your consumption.
So it's just been reset. So we're at 0 at the moment, because it's going to be compared later on.
Yes, it's going to be compared to us Mercedes-Benz test drivers.
No pressure then?
No pressure. We drive this way and then we turn right and drive around.
So we've got various different modes of drive, because there are 4 different stages for generation.
Yes. So basically with the pedals you can choose how much recuperation you want to have. The one pedal drive would be the most efficient drive to drive the EQXX, because if you do not touch the brake, then the brake pads will not touch the aluminum disc brakes of the EQXX, and this way you do not waste any energy, so you harvest the energy through the recuperation.
I get you. So you would drive it pretty much always in D and just use a lift off of the throttle?
Yes, then we control with the throttle how much we do, how much power we recuperate. When we have the possibility to freely coast, then we use D+ as well. So if it goes downwards, then we use D+ and let the car just roll, because this is the most efficient state the car can have, because then you do not use any energy at all. And when we're up this hill here, you can just let the EQXX roll, and then I'm really interested in your impression of the EQXX, how good it rolls. Foot
off the throttle in D+, the speed is obviously not going down.
Yes.
It just maintains and carries you forward. The silent smoothness of barely consuming battery at all. So this is where I'm keeping my eyes on the battery discharge.
Yes.
But as we come towards a turning,
then you would use the recuperation to gently just break down the vehicle by recuperation and get this energy back into the battery. Yeah, we turn right here, and
this is the kind of battle between driving normally but also driving as efficiently as possible.
Yes, and what's great about the EQXX is it really feels like a normal car. It feels like a Mercedes, you know, it's a complete car. It's pretty mature, actually. That's what I really like about it, and it's fun to drive. We turn right here, exit at the roundabout. So for me as an engineer, that was a special moment in time when I drove the EQXX for the first time, because you know all the data, and with some experience you can derive from the data how it's going to feel, but to be in the real car for the first time and to feel the steering wheel, how the steering feels, how the car behaves, that's something really special.
So this is where a bit of D+ to make sure.
Yeah, you can just let it roll.
But obviously we're going downhill, so it rolls and builds up the speed, so we have to hold it back a touch.
You would go too fast then, and there would be the voice indicating you that you're going too fast, because we are on a proving ground, and the speeding is watched, actually.
Yeah, so we've got to be super careful with this. I'm just learning the feel. Obviously we're sat quite low to the ground. It feels like a very sporty car from that sense. But it's all about demonstrating the capabilities of aerodynamic efficiency and maximizing.
So we started this as a technology program to further develop electric vehicle technology, and the EQXX is our start of this technology program, and we have been really successful with which shows in the EQXX. We turn left here.
Got to try and minimize slowing down as much as possible.
Yes.
Carry the speed. Okay. Nice flowing section. Back to D+ for the moment.
Perfect. And you go down and you roll and the speed increases.
It's a very unusual feeling, the way it glides. I mean, when you drive in any electric car for the first time, obviously the sense of gliding is unfamiliar. It's you know, the way it holds its speed, maintains its speed, carries it through.
Yeah.
But the way this does it is another step on from that. It's another complete.
Yeah, it takes it definitely to another level. So we optimized a lot of small things, and all those small things put together is what gives you this extreme range that we have realized with the car. I mean, we even went further than we targeted in the beginning. You know, we had this target of 1,000 kilometers. Now when we went to Silverstone, we suddenly realized, well, yes, we can go further, and then we did it. We said, just let's do it, let's push it as far as we can go with this trip, and we had this 1,202 kilometers then that we realized.
Which is just unbelievable to have achieved such an extraordinary range. Because even now we're cruising at 60-something kilometers per hour, and other than the small section uphill, it's just using 1 kilowatt.
Yes.
Incredibly efficient. This is definitely making the most of rolling here as we go back downhill.
Yeah.
Just let it do its thing. I feel like the car creates this sense of how you have to drive it as delicately and carefully as you possibly can, but then you've got to be aware of the corners and slow down a little bit. So a day like today is 35 degrees Celsius.
Yes.
What impact does that have to this? I mean, it obviously helps with the solar cells, but heat.
But this is very interesting for us engineers right now, because we designed this vehicle for long-range drives, obviously, and today we're doing journalist drives where the car is at lower average speeds, and it sure affects our air condition, but we build in an air condition into the car. And also we are looking at all the thermal data, because we are not having a liquid cooling of the battery, but we do not need it. And this is what we also realized through drives like Silverstone, where we had 30 degrees in the UK as well. And we saw in the data that the car can do it. And we throw constantly new challenges at the car, and we're always astonished on how good the car handles it, to be honest.
Yeah. Well, while the air conditioning might not be the best for total efficiency, I'm enjoying it.
Me too, yeah.
So
it would
hot
be
today.
boiling hot in here.
But even now, 0.9, just rolling, and still the numbers build up. Oh, it's fantastic to experience this. It just wafts along. It's like a nice new experience. It's a bit of a learning experience, but it's very different to what we typically associate with, with a car. It's different. It's a different approach.
Yeah. And how do you like the cornering of the car? How do you like the total feeling?
We're not throwing it into corners, of course, but it feels good. It feels nice. It doesn't feel like it's a floaty, big, heavy thing. It feels much more sporty orientated. It's the balance between how aggressively do you go through the corner versus
true.
comfort versus.
Yeah, this also was stuff where we looked into how much does cornering affect the driving resistances. That's something that we also took a close look into, and took it into account for our simulations for the drive down to Cassis.
Yeah.
Because we absolutely wanted to know beforehand if we can achieve it, and how we can design the car to really achieve those 1,000 kilometers.
Yeah. So here, going uphill around a corner, I've got to decide the balance of holding speed versus...
True, yes, yeah.
All meanwhile in silence. And now I know around here we have a gate, so... Gate open. Just.
Yeah. Very good. Yeah, you did not come to a full stop. You catch the energy while rolling. That's good.
So you have to brake.
Okay, good. May I want to just check out your consumption. Where is it?
9.4 kilowatt hours.
9.4. Yes. 9. Is this since reset or? No, this 8.3. This is the consumption since reset. Yeah, 8.3 kilowatt hours per 100 kilometer.
That sounds good. It's about even. Oh well, it's just gone to 8.4, but we were stopped on 8.3.
Yeah, that's because of the air condition, sure. And then now it goes up because we're standing still and the air condition is running. So
the same as you achieved on the long journey.
Yes, it's the same. And this has been a route where you accelerated and you recuperated energy and everything. So I think it's a really good value, especially taking into account that we are having the air condition running the whole time, and we are having 35 degrees outside temperature.
Yeah, hot. Well, thank you. Awesome.
So now you drove very efficiently, which you have done very well, and now I would like you to have the sensation of accelerating the EQXX and see how good it does that.
So driving kind of like a normal car again?
Yes, drive it like a normal car around here, and then you'll see that it accelerates quite well, actually. We have 180 kilowatts of mechanical powers at the wheels, which for a lightweight car like this is already giving you quite a good acceleration.
Yes, because when I calculate that, and I consider it's 240 horsepower,
yes,
in more traditional numbers, your instinct is, well, that's not a whole lot.
True.
If you're used to driving high performance cars or sports cars. But that actually picked up impressively.
Yeah. Because
you still have instant torque because electric motor.
Yes.
Yeah, not bad.
Not bad, isn't it?
Obviously, the very low weight of the battery, the low center of gravity, you feel that here completely because the car sits dead flat.
Yeah.
The one pedal driving is the strangest sensation. You get used to it.
Yeah, you need to get used to it, yeah.
A quick look myself then, while we're here, at the dashboard and some of the different screens and how you swipe this through and across the different modes that we were talking about a little bit while driving. Your energy usage, for example, the summary and other data. Obviously it is still a Mercedes and you've got lots of screens, and this is where you have your diffuser setting and you can choose exactly how that is. But all of the finishing and detail inside here, you know, these 3D printed components, the air conditioning vents, they are all functional and all here, and it's a 4-seat configuration with those two almost bucket-esque style seats behind and the same trim and finish. You're sat low to the ground, although conscious that the A-pillars and the roofline are pretty close to your line of vision, but still equipped with the vignette from Switzerland, required to drive on the public roads in Switzerland because, of course, this car has been used for exactly those purposes. I suppose, though, for the time being, I need to step out. We will go and look at some more of the components, but what an interesting drive this has been in the EQXX. You know, when it launched, this was a car that immediately got a lot of attention because it looks fantastic, and that's one of the challenges, I think, for electric cars and for aerodynamics. To reduce drag coefficients is to keep it with impressive looks, to keep it, in this case, looking like a Mercedes, but not only a Mercedes, a very sporty future Mercedes, a standout model. That was a really interesting drive, but I want to show you a few more things before we have some final thoughts on the driving experience. Come on in here then, where we have the full demonstration and display to take a look at. We've got another EQXX here at the moment, but I want you to feast your eyes in this direction because we've got quite a lot to check out to understand more of this car, as I mentioned. And the first thing here is the battery pack, and you can see quite how, well, low this is, the flat floor effectively of the entire car. And obviously battery packs are a very rapidly evolving technology to be able to reduce the weight, increase the power, also reduce charging times, manage the thermal properties. And this is the next generation, the next chapter of this, to be able to make the whole system just 495 kilos. If that was, you know, double, it would have a huge impact on driving. Although what I found particularly interesting to find out is that adding about 85 kilos to the car's weight is the equivalent of 0.001 in the drag coefficient. So if you add 85 kilos, it only goes up to 0.171. It's not a huge element. The aerodynamic element of it is significantly stronger. If we come through, though, beyond the battery, another topic is to talk about the wheels and the tyres. And we had a quick look at these, and you've got all these lovely rose gold details just to obviously give it a visual appearance. But it's a magnesium wheel, 20-inch wheel. Obviously magnesium is very light, very expensive, but you also have these clear covers with the circles in rose gold behind, and the clear covers are about helping keep it as smooth as possible for the air across the face. Now the tyre, developed by Bridgestone specifically for the purpose, is a quite narrow tyre compared to sports cars at 185 section, but you can see from the shape it's very curved. Again, the shape is all about the aerodynamic side of it. Every single element of this has had attention paid to it to make sure that it's as good as possible for the purpose. If we come further through, we have parts of the frame, and you can see again how these shapes are all optimized to basically take the weight out wherever it isn't needed. By having shapes like this, computers can calculate the strength that you need, obviously, for the rigidity of the car, but without having the excess material, which would just bring in a whole load of weight that you don't necessarily want on it. Now over on this shelf, we have a lot of materials. I don't entirely know where to begin with it all, but you can see the extent of the sustainable materials that they're trying to use and trying to incorporate into the car. And when you pick up parts like this, that weighs nothing. That must be 5 grams or something. Obviously, these 3D printed sections not only look amazing, but also taking out more excess weight that you wouldn't necessarily need. For parts here, you have vegan-based silks, for example. The bamboo for the floor mat, made from 100% natural bamboo fibers. Everything is about saving weight everywhere they can. A bit more information about the 3D printing, one of the greenest thermoplastics there is. Household waste recovered from landfill used for the 3D printed components. More materials and just everything around, as you can see. The Dynamica material, sustainable microfiber, the different textiles, different trims, and some more of the raw ingredients really that go into all of that. And obviously this is all very relevant because this is what we're going to see in our cars in a couple of years' time, if we don't already. Some of these we're already seeing. This is technology aimed at, well, pioneering the industry, but also at what we're going to be driving. You know, while this isn't a production car as we see it, the EQXX is not a car that's going directly into production. It does represent many elements that we will see in production cars of the future. For example, we have already the EQS and the EQE in the Mercedes family, but there's a gap for an EQC to sit a little bit smaller than that, and the facial imprint of this is perhaps EQC size. So maybe we'll see some elements of this coming into a car of that kind of position in the lineup. Who knows? Perhaps a supercar, perhaps, well, a super electric saloon. Who knows which direction that will go? I just find it fascinating how the rear track is 30 millimeters narrower on each side. So about 60 millimeters, 6 centimeters, 2.5 inches or so narrower at the back than the front. And that's obviously a battle between designers and engineers. Engineers, and certainly aerodynamicists, will always favour a narrower rear track because it means you have more of that teardrop style cabin shape, whereas a designer will of course veer the other way because you want to see a car with wide arches at the back, very bulbous arches, and you get a bit of that with the shape. By the cabin itself significantly tapering off towards the back, you get that haunch over the rear arch, you get that shape that gives it the sporty look, you get that feeling from it, while it then carries down towards that very sleek back end. So it's a car that when you start studying and looking at in more detail, you realise quite how far they went with it. There are so many elements, so many very clever things about it, but clearly that was all to great effect, given it managed to drive 1,202 kilometres, 747 miles on a single charge. And I have the feeling that if they did that not using the air conditioning, they had the AC on for 8 hours of the 14.5 hours on that drive on a really sunny day to maximise the solar panels and the effect of recharging it. 1,300, 1,400, who even knows where it could get to? Fascinating to think about. Anyway, today has been mega. To experience the car, to drive it, to get a feel for that complete elimination of rolling resistance, the fact that it just allows itself to waft on, to cruise down the road, to effortlessly glide around the test track, the proving grounds here at Immendingen. Unlike anything I have driven before, I did actually go out just previously for a brief understanding of it in Emma, which is an EQB running this powertrain, a car, their prototype car, so to speak, of the EQXX. And you drive in a different way. You're using the paddles to go up and down between the different recuperation modes to get what you want out of it, and then to drive and see how flat it sits at the end when driving a little bit more aggressively. Again, quite impressive. So it might only be 241 brake horsepower, but they're very effective brake horsepower. That's it for today though. Thank you very much for joining the experience. As always guys, I hugely appreciate your support and I hope you've enjoyed coming along for the ride. That's it for now though, and I'll see you again very soon. Cheers!